OBVP program is to address applications of new and emerging technologies and to pursue improvements to the methods of generating AC power for military theaters. The OBVP program objectives were to generate a technology that could produce 10 kW of power available for tactical wheeled vehicles. This power would originate from the capabilities of the vehicles and would therefore eliminate the need for a vehicle to have a trailer-towed approach for power generation. This in fact created a more robust, more mobile system that could be used in different theaters. It also allowed for more cargo space to be used without having to have a trailer-towed approach. As the development continued, additional applications were realized within this program. The original concept was for the VPS-10K to be a backup power source for a sentinel radar system in stationary mode. But as the technology advanced, we found ways in order to incorporate moving power into the power inverter. The system architecture gathers its power source from the vehicle itself, utilizing a Niehoff 28-volt 400-amp alternator. This alternator ties directly through the battery and into the power inverter. Communications are set up between the power inverter, the vehicle, and the speed controller interface, where monitoring and sensors from the vehicle. An adaptable speed controller was also designed within the system so that we could maximize the output performance while providing fuel economy for the system. The function of the speed controller is to monitor the output load as well as monitor the vehicle itself. It will monitor this load and access it to the accelerator on the Humvee, therefore allowing it to provide the optimum amount of RPM for the load provided. Should that increase, the accelerator will increase, therefore increasing the RPM to provide load for those applications. Also included within the system is a user's interface box mounted to the dashboard, which gives the operator instant readouts and information pertaining to the load that's applied to the system. Should the Humvee require more RPMs to apply to the load, the indicator box will give this information to the operator, telling him to either speed up or increase the RPMs on the engine speed or the alternator. If his RPM or engine speed is too high or higher than anticipated needs, it will also provide him with that information as well. Within the system also is a customized software package that can be set up as a calibration mode so that the power inverter may be customized for the specific vehicle for the retrofit. Also included in this, via USB interface, is calibration software. This can be used to customize the installation of the VPS-10K into the vehicle that the specific retrofit is targeted towards. Included in this as well are things so that fault condition tracking can be monitored, graphs and other types of diagnostic information can be gathered from the power inverter itself. This is very useful whenever you're setting up the system or if you have to maintenance the system. Mechanical construction of the power inverter is composed of 3 phase module assemblies. Each of these represents phase A, B, and C of the power inverter for 3-phase operation. In the event one of the phases should fail, the unit will still operate in single-phase mode. This makes it much easier for assembly and serviceability. In replacing these, it's a simple task of removing screws, unplug the module, and then plug in a new module. Retighten the screws and you've just installed a new environmentally sealed module that will now operate in 3-phase operation. Demonstrations were held to show the VPS-10K in an actual retrofit of a Humvee. During the first phase of these demonstrations, the load was a light bank that represents up to 6 kW of power. And in this demonstration, the loads were increased per phase as they ramp up from 1.5 kW to 6 kW and then back down. As you can see in the demonstrations, the speed controller reacts to the load, applying the appropriate RPMs based upon the amount of current that's being drawn from the VPS-10K unit. The user's interface box and the graphical user's interface software will demonstrate and show to you the actual RPMs that are being pulled from the alternator, the RPMs that are across the vehicle engine itself, the current that is drawn on the system, the power that's applied on the output of the system. After development was made and future enhancements added to the system, further demonstrations were used and conducted with multiple loads. In these multiple loads, they include inductive loads that were represented by a three-phase fan. There were resistive loads that were used, and light bank loads were also applied during this demonstration. Power levels during this presentation reached up in the magnitude of 9.5 kW. Future plans and moving forward for the OBVP program are higher power output levels, where we want to obtain 30 kW and then move forward into 60 kW and beyond. Other vehicle retrofits that we're looking at are the FMTV and the HEMT, as well as providing power on the move for tactical operation centers so that mobile power can be available for video, satellite, networking, and any other applications that might come up for those. The development work for this program focuses all its efforts in providing a solution never before seen by the Armed Forces. This method of power generation provides the capability of achieving power levels only seen in the past by the utilization of the Trotter-Totem approach. This provides the soldiers with more options in accomplishing objectives without having to jeopardize safety because of limits imposed by previous solutions. Flexibility, mobility, portability, and durability were the main points of design during development. With the VPS-10K, those objectives were achieved.